Hello. I'd like to go through this limiting reagents practice number 1 with you just a little bit, a few problems. So I have my periodic table with the backside for double replacement and single replacement reactions. I have my calculator and pencil, and I'm ready to go. So this first problem is just to get you thinking about what's going on here. So I think that this is all logic and you can do that by yourselves. So we'll just move on to question number 2. Very few solvents can dissolve gold. However, gold will dissolve in the acid mixture known as aqua regia, so like royal water. Interesting. Royal water is nitric acid and hydrochloric acid mixed together. It is some nasty stuff. You end up with a 1:1 to 3 to 1 to 1 to 2 mole to mole to mole ratio. The question says how many moles of gold? So I look on here and say I need to figure this out. MOL. That's what I need for my answer. How many moles of gold will react perfectly with, say, 3 moles of HCl? So I have 3 moles of HCl. So I look at the molar ratios and I say I have a 3 to 1 mole to mole ratio. When I put them in the test tube or whatever, they react with exactly this ratio. 3, that's how much I actually have. That's not my ratio, that's how much is actually in there. I have 3 moles, 3 times 6.02 times 10 to the 23rd particles, whatever. And so 3 is to 1, as 3 is to, pretty easy, 1. I'll get 1 mole of gold. Let's do this problem down here. What if I had 9 moles of HCl? 9 moles of HCl. The question says how many moles of gold will I get? 9 moles. So I say 3 is to 1, as 9 is to, let's see, that's pretty tough. I better write it down. 3 is to 1 as 9 is to x. Cross multiply, 3x equals 9. Divide both sides by 3 and my answer is 3. So 3 is to 1 as 9 is to 3. So my answer is 3 moles of gold will react. Let's take a look at some problems over here. HNO3 has a 1 in front of it. Gold has a 1 in front of it. And those are mole to mole ratios. So what if I had 2 moles of HNO3, 2 moles. All right, I'd say 1 is to 1, 1 is to 1, as 2 is to x. 1 and 1 are the same number, so my answer is 2. So I should need 2 moles of gold for this reaction to occur. Let's do this one. 0.0067 grams of HCl. So I need to write kind of small, 0.0067 grams of HCl will give me how many moles of gold? Well, I need to recognize that this is a 3 to 1 mole to mole ratio. So I need to get the moles of HCl first. And to get the moles of HCl, I need to use my little calculator. Moles equals grams divided by molar mass. So I've got 0.0067 grams given to me, divided by molar mass of HCl, which is 1 plus 35. Use your periodic table, that's 36. And so my math is 0.0067 divided by 36 equals 0.0001. I'm using 2 sig figs here. 0.00019. 0.00019 moles. It's a 3 to 1 mole to mole ratio. So I say 3 is to 1 as 0.00019 is to x. Cross multiply, 3x equals 0.00019. So take that number, divide by 3. My answer is, ooh boy, 0.0000. I'll put it here, 0.00062 moles of gold. That's how much I'd be making. Alright, that's how those work. Let's go down here. So how many grams of gold 3 chloride can be produced by the above reaction? Here's gold 3 chloride right here. Gold 3, gold is in the middle of the periodic table. The Roman numeral 3 means gold has a +3 charge. Chloride, I see on the periodic table, chloride gets a -1 at crisscross applesauce. AuCl3 is my formula, so I need the grams. So I'm going to have to calculate those grams, I think, using moles times molar mass. So So I need to figure out the moles of this, and I also need to know the molar mass, grams per mole. Alright, so what information am I given? 3 moles of gold. Here's where gold is, 3.0 moles. So it's a 1-to-1 mole-to-mole ratio. So I'll have 3.0 moles of gold 3 chloride as well. 3.0 moles. All I need to do now is calculate my grams. Grams equals moles times molar mass. My molar mass of AuCl3 is going to be 197, I think, for gold, plus 35 times 3, which is 105.
105 plus 197 is 303. 303, sorry, this is hard to see. 303 grams per mole times 3 moles.
909 grams of gold 3 chloride. That's my answer. So now we're going to start working on figuring out the limiting reagents. Okay, so the reaction begins and the reaction eventually stops. No more reaction is occurring. Okay, because something runs out. Now, sometimes it's one reactant, sometimes it's another reactant. Once in a while, both reactants, hint hint, run out at the same time. I'll do this one here. 2 moles of gold, 3 moles of HCl. 2 moles of gold and 3 moles of HCl. MOL. Remember, it's moles, it's not grams. All right, which one's going to run out? Here's how you do it. Sounds a little goofy, but do it anyway. You say 1:3, and then you cover this one up. You can run it either direction. You say 1:3 as 2 is 2, 3 times as much as 2 is 6. And you say, come on, 6, got to have 6 in this test tube, got to have 6. Do I have 6? No, I only have 3. This is the limiting reagent. And what's important, next step, this is the number that you're going to use for all your subsequent calculations. You have to know what the limiting reagent is. By the way, the gold is called the excess, EXCESS, because when you put this stuff in the test tube, you ran out of this, but there's still some gold in there ready to go, but it just couldn't find anybody to react with. So this is the excess reagent. I'll be likely to ask you questions pretty soon like, hey, how much too much excess do you have? In which case you'd say, well, let's see, 3:1 as 3:1. So I'm going to use one of these moles of gold, and I'm going to have the other mole just sitting there forever and ever and ever, never reacting. Okay, let's try this one. 3 moles of gold are put in a test tube with 9.1 moles of HCl. Which one's going to run out first? Which is going to be limiting? 9.1. So I have moles already. So the hard work's done. All I have to do is use my logic and say, in this reaction, I'm going to have a 1:3 ratio. That's how they will react in that test tube. So I cover up the second one, usually, and I say 1:3 as 3:9. And then I go, hey, come on, 9, got to have 9. Do I have 9? Oh, I have more than 9. I have 9.1. This is the excess. Well, which is the limiting? This one's the limiting. Now, I could have done this backwards, too. I could have just as easily, because it's all just logic, use your common sense here. You could have said 3:1. Now I'll cover up this one. 3:1 as 9.1 is to, I think it's 3.3. And I'd say, come on, 3.3. Do I have 3.3? 3.3? Oh, no, I don't. I only have 3. So either way I do this, I find out that this is the limiting reagent, and that number, 3 moles, is what I use to calculate all these other numbers. For example, if Jurgen said, hey, kid, how many moles of water would you make? He'd say, well, let's see, 1:2, that's twice as much, as 3:6. Or if I said, hey, how many moles of NO, nitrogen monoxide, would you make? He'd say 1:1 as 3:3, 3.0 moles. I'd probably ask you how many grams of this, and to get grams you'd say, well, it's moles times molar mass. So 3.0 times 14 plus 16, whatever that is, and boom, you're good.
All right, 15 grams gold, 15 grams of hydrochloric acid. Let's see, molar mass of AU is 197, moles equals grams divided by molar mass. 15 divided by 197, boom, we got 0.076 moles of gold. 15 grams divided by 15 divided by 36 is 0.42.
0.076, 0.42. 1 is to 3 times as much as 0.076 is to, let's see, 4-ish. 0.24, 0.24, 0.24. I have way more. But I knew that before, really. I'm going to run out of the gold. I could also do it this way. I could say 3 is to 1 is 0.42 is what's a third of 0.42. It's like 0.16-ish. Do I have 0.16, 0.16, 0.16? Nope. This is my limiting reagent, so I use this number to do all my calculations. Please circle the limiting reagent. Determine how many moles of product will be formed. Let's do it. You have P is from the right, O is from the right. It's a molecular compound, covalent bonding, diphosphorus pentoxide, plus 3 waters makes 2 phosphoric acids. Okay. Let's balance it. It's balanced for us already. It's a 1 to 3 to 2 mole to mole to mole ratio. All right. So somebody, somewhere, put 8 moles of this in a test tube with 23 moles of this. Don't have to do any work on this. Let me just go to my thinking, all right? So I say 1 is to 3 times as much. 1 is to 3 as 8 is to 24. Come on, 24, do I have 24? Do I have 24? Nope, I only have 23. This is the limiting reagent, and so it says circle it or underline it, whatever you want to do. So that's my limiting reagent. This is my excess. There will be some extra of this when I'm done. And then it says how much of the product will be formed. Well, I've got a 3 to 2 ratio. Well, I don't think I can do this very accurately in my head, so I say 3 is to 2.
3 is to 2 as 23 is x. Cross multiply. 23 times 2 is 46 divided by 3. 46 divided by 3, 15.3.
15.3 moles of this will be made. Next question I'll probably ask is how many grams is that? Well, to get the grams, you need the molar mass of H3PO4, so you'd say, let's see, 16 times 4 plus 31 plus 1 plus 1 plus 1 is 100 and about 100. Don't use the 2, 1,530. There you go. Let's do one more problem. KCl plus O2 yields KClO3. All right. In the lab, a long time ago, I burned a pencil. And to do that, I put some KClO3 in the test tube and I heated it up and it started to decompose. Well, this is a composition or a synthesis reaction, so this is the opposite of that reaction. Maybe you sort of recognize it. Let's balance it. 1K, 1K, 1Cl, 1Cl, 2, uh-oh, sets of 2, sets of 3. How many sets of 3? How many sets of 2? I need 3 sets of 2 to balance 2 sets of 3, but I just wrecked my K's and my Cl's, so I need a 2 there. We have a 2 to 3 to 2 mole to mole to mole ratio. All right. Oh no, I only gave you grams, I only gave you grams. All you have to do is calculate the moles, using moles equals grams divided by molar mass. 1.8 divided by K is 39, Cl is 35, together that's 74 grams per mole. Small number we're going to have, 1.8 grams divided by 74 equals 0.024, 0.024 moles. Let's get the moles of this. Moles equals grams divided by molar mass. 2.5 grams divided by, this is oxygen all by itself. Oh, it's one of the lucky 7. One of the lucky 7. All right, so that means I have a 2 there, I have a 3 there. Don't use this 3 for the molar mass, just use the 2. So I look at the periodic table, I see it's oxygen, that oxygen is 16. I've got 2 of them, 32. So 32 grams per mole. Moles equals grams divided by molar mass. 2.5 divided by 32, 0.078. 0.078, all right. 2 to 3 ratio. 2 is to 3, that's 1.5 times more, as 0.024 is to 0.036. 2 is to 3, as 0.024 is to 0.036. All right, come on, 0.036. I need it. Come on, 0.036. Do I have it? Ooh, I have 0.078. Way more than I needed. This is the excess. So this is the cool one, the limiting reagent. When this is gone, reaction stops. And so the next question is, all right, how many moles of KClO3 are you going to make? Well, it's a 2-to-2 multimole ratio based on my limiting reagent. 2:2 as how much do I actually have in my little teeny tiny test tube? I only have that little tiny amount. 2:2 is 0.024 is to 0.024. Game over. Next reaction, make sure when you're doing this, you go like, well, this is a single replacement. Is it going to occur? Let me look. Yep, it sure will. Mg here, so Mg is going to be the Cl, and you go, well, Mg gets +2, Cl gets -1, crisscross, oh, that's my formula there. And then over here, you're going to have some hydrogen all by itself. That's one of the lucky 7, so when you write down H right here, you know what to do. It's H2. Peace out.